Welcome back, my dearest students. It's so good to see you. You're coming back as a champion, as always you are, alright? Well, do you remember Mr. Max said I got some surprise? Alright, we're going to talk about that, which will be on the multiplication. Also, we're going to talk about the division also. Let's start with multiplication, okay? Dealing with decimals, alright? So, let's say for example, if I were to give you 3.4 times 6. Alright, I'm multiplying a decimal with the whole number. Now, the method I'm going to explain to you is called forget it now, remember later. Forget now, remember later. Okay, keep in mind. What is that? Forget now, remember later. Okay, let's write that down. Forget now, remember later. Okay, what does that mean? All right, the decimal. We're just going to forget the decimal. Pretend there is no decimal. So it's going to be 34 times 6. Okay, remember we're just doing the first step, which is forget now. We're just forgetting the decimal. All right. So whenever you have multiplication like this, you never try to multiply like this. What do? You line it up. You line it up like this. Okay. Now 6 times 4 is 24. So you're going to put 4, carry 2. 6 times 3 is 18. Plus 2 is 20. See that? See how timetable is coming so handy right now? That's what Mr. Mac always said. Make sure you know your timetable. Okay? Make sure by now you should be knowing all your timetable up to 12. So you will tell me that you don't know timetable by now. Mr. Mac will not be happy. I know you do. Because why? Because you belong to Score A Math Week 3 and you're Mr. Mac's dearest student. If you don't, turn it off. Go learn your timetable and then come back. Alright? Okay. Come back here. Okay. Alright. So now, remember we said forget now. So we already multiplied it. Alright? We got 204. But that's not the answer. Because you got to remember later. Remember later. That means you're going to remember back the decimal. How many numbers behind the decimal? Only 1, isn't it? So count 1. Put the decimal right there. Okay, so its answer is 20.4. Very important. Forget now, remember later. Alright? Now let's say for example, if I give you 7.5 times 2.6. Alright? Look at this. Both are decimal this time. What are we going to do? Forget now. We're going to forget about the decimal. Forget it. Forget it. Alright? We're going to do that. So it's going to be 75 times 26. We're going to pretend like 75 times 26 right now. Okay? So we're going to line it up. So we're going to put 75 times 26. 6 times 5 is 30. Okay? So we're going to put 0, 3. So 6 times 7 is 42. Plus 3 is 45. So 5, 4. Now we're going to do the 2. So always line it up right there. We're going to start right here. Okay? 2 times 5 is 10, 0, carry 1. 2 times 7 is 14, plus 1 is 15. So 5, 1. So now we're going to add them, alright? 0, 5, 4 plus 5 is 9, 1. Now wait a minute. Are we done? No. Because why? Earlier we said forget the decimal. Remember later. We're going to remember it right now. Okay, find out how many numbers behind the decimal. 1, 2. Make sure both of them, add them, alright? 1, 2. That means 1, 2. Right there. So it becomes 19.5. That 0 have no value, drop it. That's your answer. That's your answer. Alright? Keep in mind, okay? Forget now, forget the decimal, and then remember later. Right there. Okay, good. Alright. Okay, so pretty straightforward, isn't it? Alright, let's do another one. Okay, let's say for example, if I were to give you 2.15 times 1.3. So what method do I use? Forget now. So we're going to forget now. Right now we're going to forget it, the decimal. So it's going to be 215 times 13. Alright, 215 times 13. So what are we going to do? Line it up. Very important. Line them up. You cannot ever try to multiply like this. Alright, so I'm going to put 13 right there. Okay, now I'm going to multiply. 3 times 5 is 15. Carry 1. 3 times 1 is 3. Plus 1 is 4. 3 times 2 is 6. Now I'm going to times 1 straight there. Very important. Straight down. 1 times 5 is 5. 1 times 1 is 1. 1 times 2 is 2. Now I'm going to add them. Straight down. 5. 4 plus 5 is 9. 6 plus 1 is 7. And then bring 2 down. Am I done? No. Why? Forget now, remember later. We're going to remember the decimal back. Count how many numbers behind the decimal. 1, 2, 3. So there are 3 numbers behind the decimal. So we're going to count 1, 2, 3 right there. That's where you put the decimal. See? Very easy, isn't it? Alright? Once you know that principle, rest is just multiplication from the timetable. Okay, good. Alright, my dear student, I'm going to erase the board and I'll be back in a few seconds. Alright, my dear students, now what happens if I have 3 decimals multiplying? Let's say, for example, okay, I got 4.2 times 1.5 times, let's say, 3.12. Right? Let's make it a bit exciting, alright? Okay, so we got 3 decimals multiplying. Very good. We're going to use the pairing method, okay? So we're going to pair this and then we're going to multiply that. Alright, so that means we're going to start with this 2. Okay, so let's take that 2 out first. 4.2 times 1.5. So what's our method is? Forget now, remember later. So we're going to forget the decimal right now. So we're going to forget it. So we're going to type 42 times with 15 right now. Okay, so we're going to line it up. So 42 and 15. Very important, okay? Line that up, alright? Okay, good. Okay, it's very important, so line it up, alright? So once we've done that, okay, let's do that. Start with 5. 5 times 2 is 10. 0, carry 1. 5 times 4 is 20, plus 1 is 21. 1, 2. Now we're going to go to the 1. Always straight down. Very important, okay? Straight down to this one. 1 times 2 is 2. 1 times 4 is 4. So we're going to add them. 0, 1 plus 2 is 3. 2 plus 4 is 6. Now, see that? Forget now. Remember later. So now what are you going to do? We're going to remember the decimal back. So go back to here. How many numbers behind the decimal? 1, 2. How many digits behind the decimal? 1, 2. The same thing you do. 1, 2. And then you put the decimal right there. Very important to bring the decimal back. Okay, do not forget. That's why it's very important to remember this principle. Okay, so forget now, remember later, because you have to bring the decimal back. So that means it gives you 6.3. We can drop the 0, so it becomes 6.3 on this one. But are we done? No, because we have to multiply this right now. Okay, so let's take 6.3 times 3.12. Now, what are we going to do? We're going to forget now. Alright, we're going to apply the forget now principle and remember later. That means we're going to forget the decimal. So we're going to multiply 63 with 312. Now keep in mind, when you have multiplication like this, always put the big number on the top, small number on the bottom. Alright, when you line them up. Okay, you can do that. Alright, with multiplication, yes, but division you cannot. Alright, keep in mind, division you cannot, but multiplication you can rewrite this like this: 312 times 63. It's allowable. Alright, okay, so that means I'm going to write 312 and then I'm going to line it up with a 63 on the bottom. Alright, okay, so now I'm going to start with 3. 3 times 2 is 6. 3 times 1 is 3. 3 times 3 is 9. Then I'm going to do 6, lining up straight down. I'm going to start right there. 6 times 2 is 12. Carry 1. 6 times 1 is 6, plus 1 is 7. 6 times 3 is 18. Now I'm going to add them. Okay, 6, 3 plus 2 is 5, 9 plus 7 is, very good, 16, carry 1, 1 plus 8 is 9, and then bring it 1. Am I done? No, I have to remember back. Okay, remember back the decimal. I'm going to find out how many numbers behind the decimal. 1, 2, 3. In other words, how many digits, alright, behind the decimal. There are 3 digits behind the decimal. So I'm going to count 1, 2, 3 right there. So it becomes 19.656. That's the final answer. So the multiplication of this one is 19.656. And that should be your answer. So it's very important, okay? You got to remember back after you multiply, all right? The decimal. So that should be your answer, okay? Good. So, well, now let's go to division, all right? So, and then let's learn about division. So, multiplication, the key thing is forget now, remember later. Well, let me erase the board and then we'll talk about division. Give me a few seconds, I'll be back. All right, my dear students. So, what are we going to use for division? It's called forget it. I like that. Forget it. We're going to use the forget it method. Okay. Now with the multiplication, what was that? Forget now, remember later. Now with the division, totally forget. Forget it. That means you're not going to remember back. You're just going to forget the division. It's not. I mean, forget the decimal, all right? We're just going to forget the decimal and we're not going to bring it back, all right? With the multiplication, we brought the decimal back, but with the division, we're going to just say forget it. That means when you say something like forget it, that means you're not going to remember back or bring it back. Am I right? So we're not going to remember back. We're just going to forget it. All right, let's put a problem up. Okay, let's say for example, I got 4.25 and I'm going to divide that with 0.5. All right? Now the thing principle we're going to use is for division is forget it. All right, forget it. All right, this is the principle we're going to use, forget it. Now the word forget it means only applies to the number that's dividing on the right hand side. This number is the one we're going to say forget the decimal. That means, what does that mean? I want to get rid of that decimal. Okay, I move it how many times? Once. The moment I move that once, you got to do the same thing with this side also once. Doesn't matter, even though there's a decimal still there, but this is the one must be without a decimal. That's how we're going to use this, forget it. We're going to forget the decimal from this one. That means we're going to get rid of, all right? So we're going to move that decimal out of that number, okay, out of that decimal number there, okay? So we moved it one time. That means I have to move it one time also. Let's say for example, if I were to have, let's say 0.02, let's say 7.68. All right, so how many times do I move the decimal? Twice, because look at that, 1, 2. In order to get rid of the decimal out of that number there, decimal number there, I have to move it twice. That means I have to do the same thing on this side, 1, 2. So that means this one becomes 768 divided by 2. This one becomes 42.5 divided by 5. See that? And you just solve it from there, and you don't bring the decimal back, and that what you get, that's the final answer. All right, let's do it. Okay, so let's do the first one. So you got 42.5 divided by 5 after we apply the forget it principle. Now remember, with the forget it principle, we're not going to remember back the decimal for the division. Okay, this only apply for the division problems. All right, so now look at this. We got a division problem right there. Okay, what method we're going to use? The long division. When I say the long division, what approach we're going to use? The cage approach. I'm going to put the cage. So 42.5 into Mr. Mac, I'm going to put inside the cage. Okay, so I'm going to put 42.5, and then 5 is kind of out, I'm going to put outside. All right, okay. Now keep in mind, the goal with the forget it principle is to make this decimal number right here into a round number, a whole number. That's why we're getting rid of the decimal by moving it. All right, by moving it twice over here, once over there. But when you move that way, you have to move the same number of time on the number that you have been divided by. Okay, all right, okay, good. So now ask yourself, in 4 there's how many 5? None. So go to next digit. 42 there's how many 5? 8, because we know that 8 times 5 is 40, minus 2 minus 0 is 2, 4 minus 4 is 0. See the decimal right there? Bring it up. Very important, bring it up. Now bring the 5 down. In 25 there's how many 5? 5, because 5 times 5 is 25. Okay, so 5 times 5 is 25. That gives me 0. So that means 4.25 divided by 0.5 is 8.5. This is part of the working, 8.5, and that's the answer. All right, that's what this is. Okay, now this is part of the working to get to the answer right there. Okay, so 8.5. Now let's take this one right there. So we take 768 divided by 2. Again, we're going to use the long division method. I'm going to use the cage approach. 768 is kind of into Mr. Mac. I'm going to put inside the cage. and the 2 is kind of out, I'm going to put outside the cage. In 7 there's how many 2? 3, because 3 times 2 is 6. 7 minus 6 is 1, I bring the 6 down. 16 there's how many 2? 8, because 8 times 2 is 16, minus gives me 0. Now I bring the 8 down. In 8 there's how many 2? 4, because 4 times 2 is 8, minus gives me 0. So the answer is, this one is 384. Alright? Okay, so 7.68 divided by 0.02 is 384. So you got to use this method. Alright, I know you'll think, wow, Mr. Mag, such a small number divided by such a small number. It is, because this such a small number right here is what's making this whole thing to be big. Okay, to give you 384. Alright, okay, good. Let's do another one. Let's say, for example, if I were to give you, let's say 6.27 divided by 0.03. So what's the principle we're going to use? Forget it. Forget it. Alright? Forget it method. I like that. Forget it. Forget it. Let's say that with the attitude. Alright? I don't know. The nice way. Forget it. Okay? You like that? Forget it. Alright? Okay, good. Alright, come back here. Okay. So what's our goal is? To forget the decimal. Alright? Because I want you to remember, when it comes to division, we're going to use the forget method. That's why I'm trying to do all this, so that you'll never forget. Okay? Alright, you'll never forget the forget it method. Okay. Alright, we're going to forget the decimal. In other words, we're going to make this into a whole number. So that means I got to get rid of the decimal. How many times? 3 times. I have to get rid of the decimal, so that means I have to move it how many times? Twice. Alright? So I grab the decimal, move it 1, 2. If I move it 2 on this, I also have to do the same thing on this one. 1, 2. See that? Right there. So now it becomes 627, divide that by 3. Alright? Does that make sense? Okay, now, what method do I use? The long division method. Okay, I'm going to put the cage. 627 is kind of into Mr. Mac. I'm going to put inside the cage. 3 is kind of out. I'm going to put outside the cage. 6 is how many? 3? 2. 2 times 3 is 6. 6 minus 6 is 0. And then in 2 there's how many 3? 0. Make sure you put 0. Alright? And then bring the 7 down. Okay? So in 7 now becomes, when you brought the 7 down, becomes 27. In 27 there's how many 3? 9. Because 9 times 3 is 27. So 27 minus 27 gives me 0. That's the end of it. That means 209 is your answer. Okay? Alright? Now what about something like this? If I were to give you, let's say 48 divided by 0.4. Remember, our goal is always what? To make this one to be a round number, whole number, okay? That means I have to get rid. In other words, I want to forget about the decimal. That means I have to get rid of the decimal. How many times I have to move the decimal? Once. But what about this one? There is no decimal for me to move. It's not there visually, but there is a decimal which you have to put it on, which is right here. Okay? So in other words, 48.0. I grab that decimal, I move it once. Same thing as this one. Only once, only once. That means this one becomes 480 divided by 4 now. Very important, okay? See, there's a decimal right there. So I grabbed that decimal, I moved it. So it becomes 480 divided by 4 now. Okay? So use the long division method. So I'm going to use the cage approach, okay? So I'm going to put the cage. So I'm going to 480 is kind of into Mr. Mac. I'm going to put the 480 inside the cage. The 4 is kind of away from Mr. Mac. I'm going to put outside the cage. In 4 there's how many? 4, 1. 1 times 4 is 4. Minus give me 0. I bring the 8 down. In 8 there's how many 4? 2. So 2 times 4 is 8. Minus gives me 0. Now since this one came to 0, there's a one more 0 on the end. Just bring it up. So it becomes 120. That's your final answer. That is your answer. We're not going to bring the decimal back. On the division, you forget it means you forget it. You don't bring it back. Okay? Alright? That's the goal. Alright, let Mr. Mac erase the board. Let's do more. I want to make sure you understand. on this division, because the multiplication was pretty straightforward, isn't it? Forget it now, remember later. With division, you got to forget it, but the part that you want to forget the division is on this side, on your right hand side, the number you're dividing it, okay, with, alright, not the number you're dividing it by. Alright, so this one, the dividing it. Alright, okay, good. Let Mr. Mac erase the board and then we'll do more. I'll be back with you in a few seconds. So keep in mind, alright, so the number that you're dividing it by, alright, not with, alright, by. So in other words, this is the one that needs to be what? Whole number, a round number, not in the form of decimal. So we got to get rid of that one to become a whole number, means we got to get out the decimal. So I grab the decimal, move it 1, 2. The same thing I have to do here. The decimal is right there, 1, 2. That's the same thing here. This one no decimal, but this one has decimal. My goal is to make this one into a whole number. That means I have to move only once. The same thing I did. The decimal right there, moved it once. It became, from 48 becomes 480. Okay, so very important. Okay, let me erase the board so we can do more problems. I want to make sure you understand good on the division of the decimal. Okay, I'll be back in a few seconds. Alright, my dear students, now let's say for example, if I were to have something like this, 42.3 divided by 0.01. So how do I do this? Now look at this, 0.01. Our goal is what? To make this into a whole number. That means we're going to forget that decimal. That means we're going to get rid of it. So we're going to move that decimal. How many times? Twice, okay? Why? Because it takes twice to move it right there. That means what I have to do to this one? The same thing. I have to move it by twice. I grab this decimal, move it 1, 2. See that? Let me rewrite this one down here. 42.3. So I grab this one, I move it 1, 2. The first bubble got 3 in it. The second bubble got nothing. You put a 0. So that makes it 4,230 because you put a decimal behind there. Okay? Divided by 1. Any number divided by 1 is what? The same number. Alright? So that means it becomes 4,230. That's your answer. Keep in mind, any number you divided by 1 will be the same number. Okay? So the thing is, in this case, you're 0.01. That's why you got to move that decimal. In this case, it needs to be moved twice. That means I have to do the same thing with this one. Move the decimal twice. And that's the key behind the forget it method. Once we forget it, we're not going to bring it back. That's it right there. That's the answer. Okay? Let's do another one. Let's say, for example, 16.5. Okay? I'm going to divide that by 0.05. Alright? So, what do? My goal is to make this one what? A whole number, alright, without decimal. That means we're going to forget the decimal. That means I have to move it. I have to move it in order for me to get rid of or forget the decimal. I have to move it. How many times? 1, 2. Alright, so that means I have to do the same thing with this one. 1, 2. The first bubble got 5 in it. Second bubble got nothing. I put a 0. So it becomes 1,650 because the decimal right there. But you don't have to show it, okay? Alright, and we can divide that with 5. So divided by 5. So now we have to use the long division method. Okay, so we're going to use the cage approach. I'm going to put the cage. Alright, the 1,650 is kind of into Mr. Mac. I'm going to put inside the cage. The 5 is kind of out. I'll put outside the cage. 1, I cannot go to the next digit. It becomes 16. 16 is how many 5? 3, because 3 times 5 is 15. 6 minus 5 is 1. 1 minus 1 is 0. And bring the 5 down. 15 divided by 5 is 3. 3 times 5 is 15. Minus gives me 0. There's one more 0 left at the end. I'm going to bring it up. That's it right there. It becomes 330. That's your answer. Are we going to bring the decimal back? No. That's only for multiplication. Okay? So you don't bring the multiplication, you don't bring the division, the decimal back for division. Okay? Good. Alright. Now what about multiplying decimal with 10, 100, 1,000 and also dividing decimal with 10, 100, 1,000? How do we do those? Okay, well, Mr. Max is going to erase that. Let's talk about that. I kept both of that at the end because I want to show you with multiplying with 100, 10, 100, 1,000 and also dividing the difference between, okay? Because we're not going to use this principle, but I got different methods called grab the decimal, move it either to the right or move it to the left method. Alright? Okay, let me erase the board and I'll be back with you in a few seconds. Alright, let's start with multiplication. Okay, let's say for example, I have 4.25 times 10. Now, usually what we do, when we're multiplying with a decimal, we use the forget now, remember later. But when you're dealing with 10, 100 and 1000, don't use that principle. Grab the decimal and move it to the right when you're multiplying. Move it to the right of you. Okay? Remember, when you multiply, the number gets bigger. Okay? So by grabbing the decimal, if I move it to the right, see the number get bigger. See that? But the number you're multiplying, in this case, you want this decide how many times you move. 1 or 2 or 3 based on the how many zeros that 10 has. In this case, 10 has how many zeros? 1. Now this only applies when you get 100 or 10 or 1000 with a 1. Okay? Okay, you can't use with a 200 or 20 or 2000, things like that. It has to be 1 or 100 or 1000. Okay? So in this case, the 10 has only 1 0. That means you grab this decimal, you only move it once. So that becomes 42.5. And you put a decimal right there, which is 42.5. Let's say for example, if I give you 37.78 and I'm multiplying it with 100. Now 100 has how many zeros? 2, and you're multiplying. When you multiply, you grab the decimal, move it to the right. To the right, very important, to the right. How many times? Twice. Why twice? 2 zeros. 1000 got 2 zeros. 100 got 2 zeros, okay? So 1, 2, and then you put the decimal right there. So it becomes 3,778. Okay, now let's say for example, if I have 25.2 and multiplying with 1000, alright? So 1000 has how many zeros? 3 zeros. That means I'm going to grab the decimal, move it how many times? 3 times. Okay, let me rewrite this one right there, 25.2. So I'm going to grab this decimal, I'm going to move it how many times? 3 times. 1, 2, 3, and then I'm going to put the decimal right there. But wait a minute, there's nothing in there. That's why we're going to talk about it. The first bubble got 2 in it. The second bubble got nothing, you put a 0 in it. Third bubble got nothing, you put a 0 in it. Very important, okay? So that becomes 25,200. That's your answer. All-right? Pretty easy, isn't it? Very straightforward, okay? So let's say if I give you, okay, let's say 64.32 times 10. Again, 10 has how many zero? 1. That means I grab that decimal, move it which direction? To the right. Alright, because I'm multiplying. Alright, very important, to the right. Why once? Because 10 only got 1 0. Why to the right? Because I'm multiplying. The number gets bigger when I grab the decimal, move it to the right. See that? Okay, see when I move it to the right only once, and I put the decimal right there, it becomes 643.2. See that? From 64.32, when I multiply by 10, it becomes 643.2. Very important, okay? Very, very important, all right? But remember that, all right? When you multiply, you move the decimal to your right, all right? Multiply. When you multiply, move decimal to your right, all right? Now we're going to talk about dividing. So when you divide, it's opposite. You move the decimal to your left. Okay, let's talk about it. All right, let me well, I think, how about we do that so we can use it as a comparison, okay? No, let's erase the board. I'll erase the board, okay? Give me a few seconds, I'll be back. All right, my dear students, division, all right? When you're dividing with 10, 100, 1000, 1000, all right? Let's say for example, if I have a 45 and I'm dividing it with 100, okay? So what do? Now first, look at this 45. It's a round number, a whole number. Where is the decimal? The decimal is right there, okay? So I'm going to take that 45 and I'm going to the decimal right there. 100 has how many zeros? 2 zeros. So when you divide, the number gets smaller. when you multiply, the number get bigger. Okay, so in this case you're dividing. So with 100, that means the 45 will get smaller. So if I grab the decimal and move it to the left, see that? When I move it to the left, see that? From 45 becomes, if I put a decimal right there, it'll become what? 4.5. If I move it one more time, becomes what? 0.45. See that? And that's what I'm going to do. I'm going to move it twice because 100 got 2 zeros. I'm going to move it the decimal 1, 2, and then put it right there. So it becomes 0.45. And that's the answer. 45 divided by 100 is 0.45. Okay, let's say if I give you 68.7 and I'm dividing it by 10. Now 10 has how many zeros? 1 0. And I'm dividing, so that means I grab the decimal, move it to which direction? To the right or to the left? To your left. Why to the left? Because when you divide, the number gets smaller. So you move the decimal to the left to you, okay? Left to you. So that means I'm going to take the decimal, I'm going to move it to the left once. Right there. Okay? So and then put the decimal right there. So it becomes 6.87. That's the answer. Okay? So let's say for example, if I were to give you 245.7 and dividing it with 1,000. Alright? Now remember, key thing is 1. Then only you can use this moving the decimal to the left or right, okay? When you multiply to the right, when you divide to the left, okay? So in this case, I'm dividing it with 1,000. 1,000 has how many zeros? 3 zeros. That means I'm going to grab the decimal and move it to the left. How many times? 3 times. Why 3 times? 1,000 got 3 zeros. Why to the left? It's dividing. The number gets smaller when you divide. See that? You got it? Okay, that means we're going to grab this, move it 3 times. 1, 2, 3. Then we're going to put a decimal right there. Now there's no number right there, you put a 0. Okay? Very important. Okay, so it becomes 0.2457. That is your answer. Alright? Okay, so that means division, grab the decimal, move to the left. Very good. Move to the left. That's the key word. Left. Okay? Division is left. Multiplication is right. And how do I know when division means left, multiplication means right? Keep in mind. Alright? So multiplication is right, Mr. Okay? Multiplication, right. Alright? Division, left. Okay? DL. Alright? Mr. DL. Just remember, Mr. DL. Alright. So if you know this one, multiplication, and you know the opposite is going to be for division. Okay? And if not this way, but you always remember that when you multiply, the number gets bigger. So the decimal, by moving to the right, it gets bigger. When you move the decimal to the left, it gets smaller. So division makes the number smaller. See that? That's how you can, another way of remembering it. Okay? So keep in mind. Alright? So very straightforward between division and multiplication. You're going to see that over and over again because we're going to use that later on. If not, not now, but later. Okay? Later in your mathematics. So it's good for you to know all this. Alright? Well, my dear students, it's time for hands-on practice. Alright? Okay? So let's do some hands-on practice. So that will give you a better understanding because you're going to put on your hands on it and work on your own. And then Mr. Max is going to come. And then we're going to work together. And then we're going to compare the notes. And you're going to feel great about it because you did it, and you saw Mr. Max doing it, and we're matching it. We got the matching answer. That's the beauty about hands-on practice. And then later on, after that, you do the quiz on your own, which is another awesome approach. Okay? Alright. Give Mr. Mac a few seconds. I'm going to erase the board and we'll call Pablo out and we'll have fun. And I'll see you in a few seconds. Alright, my dear students, are you ready? Are you ready? Are you sure you're ready? I know you are. So you are ready to do some hands-on practice? Good. Well, let's call Pablo out, all right? Let Mr. Mac call it. Pablo, come on over, Pablo. Our dear students are ready for some hands-on practice. Hand over, Pablo. Have fun with it, and be sure to pause the video and then come back and have Mr. Mac in. All right? Have fun. Oh, good. Whoa, Pablo, you've been busy. All right, good. All right, let's do it. All right, let's look problem number 1. Problem number 1 says solve the following. Okay, they are all a multiplication. And you're given A, 1A, 2.4 times 6. All right, so we're going to, what principle we're going to use? Forget now, remember later. All right, so we're going to forget about the decimal on the 2.4, so it becomes 24 times 6. Now in this case 6 is already a whole number, alright? So we're going to leave it the way it is, okay? So we're going to line it up. So always line it up. 24 times 6. So 6 times 4 is 24. So we're going to put 4, 2 carry. 6 times 2 is 12. Plus 2 is 14, okay? So 14. Now, are we done? Not yet. Why? Because we forget now, remember later, the decimal. So how many digits behind the decimal? 1. So we just put 1 right there. So we count 1 from the back and then we put the decimal right there. So that means the answer is 14.4. So 14.4 is your answer. Okay? Good. Alright, let's look problem number B. Now B, you're given, okay, B, you're given 3.6 times 1.2. So what do? Exactly. Forget now, remember later. We're going to just forget the decimal for both of them. So it's going to be 36 times 12. So what's our next step? Lining them up. Alright, line them up. We're going to use the long multiplication method. Alright, very important. Okay, 2 times 6 is 12. Carry 1, put the 2 and then carry 1. 2 times 3 is 6, plus 1 is 7. Alright, now we're going to times with 1, line it up, straight down here, we're going to start right there. 1 times 6 is 6, 1 times 3 is 3, and then we're going to add them. 2, 7 plus 3 is 13, 7 plus 6 is 13, so 3 carry 1, 1 plus 3 is 4, so it gives you 432, but remember, we have to bring the decimal back, so we're going to count how many digits behind the decimal total. 1, 2. So there's a 2 digits behind the decimal. So that means we're going to bring that back, count from the back, 1, 2, and then put the decimal. So it becomes 4.32. So this one is 4.32. Should be the answer for this one. And then the answer for this one is 14.4. Okay, let's look problem number C. Now C, you're given 4.3 times 0.3 times 1.2. So you're multiplying 3 decimals. So what method we're going to use? The pairing method. We're going to multiply this first and then we're going to multiply with that. So let's start with 4.3 multiplying with 0.3. So we're going to use the forget now, remember later. So we're going to forget the decimal. So we're going to put 43 times 3. So we can line it up. So 43 times 3. 3 times 3 is 9. 3 times 4 is 12. Okay, so that gives you 129, but we're going to bring the decimal back. See that? So we're going to find how many digits behind the decimal. 1, 2. Okay, so 1.29. All right. So now remember, we're only doing the first pair. All right. So which is 1.29. So we're going to take the 1.29. We're going to multiply that with 1.2. See that? 1.2. Again, we're going to forget the decimal, alright? So that means it's going to be 129 times 12. We're going to line it up. So 129 times 12. 2 times 9 is 18. 8 carry 1. 2 times 2 is 4. Plus 1 is 5. Alright? 2 times 1 is 2. Now 1, you want to start right there. 1 times 9 is 9. 1 times 2 is 2. 1 times 1 is 1. Then you're going to add them. 8, 5 plus 9 is 14, 4 carry 1, 1 plus 2 is 3, 3 plus 2 is 5, and then you bring 1 down. And then what do we do next? Exactly, we're going to remember the decimal back, okay? So how many numbers are there behind the decimal? 1, 2, 3. 1, 2, 3, right there. So it becomes 1.548. Alright, so that means 4.3 times 0.3 times 1.2 is equals to 1.548. You got it? Good job. Okay, good. Now let's look problem number D. Now D, you're given 15 times 4.2 times 0.2. Right? Now again, we're going to use the pairing method. We're going to multiply this two and then we're going to multiply with that. Now keep in mind, this one's already a round number. It's only this is the one that's a decimal. So we're going to have 15 times 42. So because we're going to forget the decimal right now. Alright? Because that's a decimal right there, we're going to forget it. So we're going to line it up. So always put the big number on the, with the multiplication you can move around. Alright? I can put the 42 first and then multiply that with 15. Alright, so now once I line it up, I can multiply. 5 times 2 is 10. 0, carry 1. 5 times 4 is 20, plus 1 is 21. Okay? And then 1, make sure line it up. Start right there. 1 times 2 is 2. 1 times 4 is 4. And then I'm going to add it. Alright, so 0, 1 plus 2 is 3. 2 plus 4 is 6. Alright, now I'm going to bring the decimal back because we know that it was 4.2, so there's one digit behind the decimal. So I'm going to bring that one digit counting from the back, 1, so I'm going to put the decimal right there. So that means it is 63.0, okay? So now I'm going to times 63 with 0.2. So 63 times 0.2. Again, I'm going to forget the decimal. That means 2 times 63. So I'm going to do 63 times 2. Alright, so I'm going to line it up. So 63 times 2. 2 times 3 is 6. 2 times 6 is 12. And then I'm going to bring the decimal back, 1. Because there's only one digit behind the decimal. Alright, because this is already a round number. Okay, so I bring it back and put it right there. So it is. So the final answer is 12.6. That's the answer. Alright? You got that? Okay, good. So the key thing is what? Pairing method. You pair this two, you multiply. I forget the decimal, give me I got 63. And then I take the 63 and multiply with the 0.2. So I forget the decimal. 63 times 2 gave me 126. And then I brought the decimal back. Alright? That gives me 12.6. Alright, so very straightforward, isn't it? Pretty easy. Okay, good. Alright, let's look problem number E. Now problem E, well, how about I erase the board, so give me some room. I'll be back in a few seconds. Alright, E, okay, so we got E 246.2 times 0.01. So what do we do? Forget now, remember later. So we're going to forget all the decimals. So we're going to we have 2,462 times 1. What is that going to be? It's going to be the same answer, okay? Because times 1 is still going to give me 2,462. Now, what do I do next? Remember the decimal back. Very important, okay? So I count the number of digits behind the decimal. I see the decimal right there, 1, 2, decimal right there, 3. So 1, 2, 3 digits. So that means I count from the back, 1, 2, 3, and then put the decimal back there. Okay, so that gives me 2.462, and that's the answer. All right, pretty easy, isn't it? Okay, good. Now let's do problem number 2. Solve the following. In this one, all the questions are on division. Okay, so let's do 2a. 2a, you're given 42.6 divided by 3. Now look at this, 42.6 divided by 3. Now, what's the principle that we were using for division? Forget it. All right, forget it. Only if the divider, okay, if the divider is in decimal. In this case, it's not. It's a round number, so we don't have to worry about forgetting about the decimal. So we're going to do it like this. All right. So we're going to take this, use the long division method, use the cage approach. 42.6 kind of into Mr. Mac. I'm going to put it inside the cage. 42.6, and 3 is kind of out, I'll put outside the cage. In 4 there's how many? 3? 1. 1 times 3 is 3, 4 minus 3 is 1, and then bring the 2 down. In 12 there's how many? 3? 4, because 4 times 3 is 12, minus gives me 0. Now look, there's a decimal right there. Bring the decimal up, okay, then bring the 6 down. In 6 there's how many? 3? 2. So 2 times 3 is 6, gives you 0. So that means this one is 14.2. Alright, now remember that our goal is always to keep this one as a round number, whole number, okay? And the question already given you as a whole number, so you don't have to worry about using the forget it now. I mean forget it, the forget it method, okay? It's not the forget it now, remember later, that's for multiplication. For division, just forget it, okay? Let's look at the next one, B. Now B, you're given 36.75 divided by 0.5. Look at this one. This one is in the form of decimal. There you go, we're going to use the forget it method. That means I have to get rid of the decimal. How many times do I have to move? Only once. That will make that into a round number, okay? 5. That means I only have to move how many times? Once. And then put the decimal right there. So that means it becomes 367.5, divide that by 5. And then what do? The long division method, okay? So I'm going to use the cage approach. So 367.5, because this one is kind of into Mr. Mac, I put it inside the cage. The 5 is kind of out from Mr. Mac, I'm going to put it outside the cage, okay? 3, I can't go to the next number, 36. In 36, there's how many 5? 7, because 7 times 5 is 35. 6 minus 5 is 1, 3 minus 3 is 0. And then bring the 7 down. In 17, there's how many 5? 3, because 3 times 5 is 15. 7 minus 5 is 2, 1 minus 1 is 0. See, there's a decimal right there. Bring the decimal up and then bring the 5 down. In 25, there's how many 5? 5, okay? That means 5 times 5 is 25, minus gives me 0. So that means this one is 73.5. Now, since we get rid of the decimal, do we bring the decimal back? No, not on the division, only on the multiplication we do that. Division, once you forget it, you don't remember it, okay? You just forget it, alright? Okay, good. Okay, so now let's look at 12, okay? Now 12, 144, so C, we got 144 divided by 0.12, alright? Now look at this. This one is a whole number, but this one is in the form of decimal. Doesn't matter about this one. This is the one that makes the decision whether to forget it or not. Alright? In this case, yes, we want to forget it. We want to get rid of the decimal. Alright? That means I have to move it how many times? Twice. 1, 2. That means I'll do the same thing with this one right here, but there's no decimal there. But there is, we just put it ourselves right there. Okay, now I move the decimal twice, okay? So let's say if I rewrite the 144 right there, the decimal right there, move it twice. 1, 2, and then put the decimal right there. That means the first bubble, that nothing in there, you put a 0. Second bubble, there's nothing there, put a 0. So that becomes 14,400 divided by 12, okay? So that turns out to be 14,400, I'm going to divide that by 12, okay? So what method we're going to use? The long division method. So when I say the long division, what should come to your mind? The cage approach. Okay, so I'm going to put the cage. So 14,400 is kind of into Mr. Mac. I'm going to put inside the cage. So 14,400 goes inside. 12 is kind of out. I put outside the cage. In 12, see this case, the first digit 1. We can't go to the next digit 14. In 14, there's how many 12? 1. 1 times 12 is 12. 4 minus 2 is 2, 1 minus 1 is 0, and then bring the 4 down. In 24, there's how many 12? 2. And 2 times 2 is 4, 2 times 1 is 2. Minus gives me 0. Now this came down to be 0, and then I got zeros out there. Just bring it up. See that? That bring the 2 zeros up. Okay? So that brings out to be 1,200. That's the answer. Again, division, once you get rid of the decimal, you don't bring it back, okay? Because we forget it, all right? We kind of like forget it, you don't remember it back, all right? Okay, good. All right, now let's do problem number D. Now let Mr. Mac erase the board so we've got some room, and I'll be back within a few seconds. Now look at D. D says 78.5 divided by a fraction, half. All right, 1/2. So D, 78.5 divided by 1/2. Should we get nervous about that? No. Why? Just convert that into decimal, because we know how to do that. We're using arrow down. See that? Then that'll become a problem decimal divided by a decimal. See that? So let's do this first. So 1/2. 1 divided by 2. 1 divided by 2. Then we're going to use the division, okay? The long division, all right? So now 1 is kind of into Mr. Mac, I'm going to put it inside the cage. 2 is kind of out, I'll put outside the cage. In 1 there's how many 2? 0. That means I'm going to put a decimal right there and add a 0 to it. Pretend, see there's a decimal, I bring the decimal up. Now pretend like this is 10. In 10 there's how many 2? 5. Very good. So 5 times 2 is 10. Minus gives me 0. So 1/2 is equal to 0.5. See? That's it. All right, it's just an extra step you got to do. All right, so now what do? We use, so once we got this both in a form of decimal, all right, what method we're going to use? Forget it method, because this one's in a form of decimal. Doesn't matter about this one. This is the one that really matters, okay? That we got to make sure this is in a round number in order able to divide, okay? So since in a form of decimal, I have to get rid, so forget the decimal, all right? That means I have to get rid of, so move that decimal away. How many times did I move it? Once. If I do once here, I also have to do once there. So that makes it 785 divided by 5. Okay, so now I have to use the long division method. Use the cage approach. 785 is kind of into Mr. Mac, I'm going to put inside the cage. The 5 is kind of out, I'm going to put outside the cage. In 7 there's how many 5? 1. So 1 times 5 is 5. So 7 minus 5 is 2, and then I'm going to bring the 8 down. In 28 there's how many 5? Exactly 5, because 5 times 5 is 25. Okay, 8 minus 5 is 3, 2 minus 2 is 0. Then I'm going to bring the 5 down. In 35, there's how many 5? 7, because 7 times 5 is 35. Alright, that gives me 0 after I subtract that. And then I'm done. Okay, so that means the answer for this is 157. Pretty easy, isn't it? Okay, good. The key thing is what? When I give you a fraction dividing with a decimal, just change that to a decimal. That's it. All right. Now back to the decimal division. All right. And then we got to make this into a whole number. That means I have to move that decimal. Become 5. How many times did I move it? 1. That means I have to move once also on that one. And that gives you 785 divided by 5. I used the long division method, and then I got 157. Okay. All right. Good. Let's look problem number E. E, you're given 0.247 divided by 0.01. So what's our goal is? To make this one to be a round number, whole number. That means I have to get rid of the decimal. How many times? Twice. Why? See, 1, 2 right there. It takes twice to make that into a whole number. Okay, that means I have to do the same thing this one. 1, 2, and then put the decimal right there. So this become 24.7 divided by 1. Any number divided by 1 should give you the same number. See that? So that means 24.7 divided by 1 is what? 24.7. That's it. Pretty easy, isn't it? Okay, good. And that is problem E, okay, for question number 2. Now let's go for problem number 3. It says solve, and you're given 3a 0.39 times 10. So when you're multiplying with 10, 100, 1000, what do? You grab the decimal and move it to the right. Why right? When you multiply, number get bigger. See that? So that's why you move it to the right. How many times do I move it? Once. Why once? 10 only got 1 0. So I only move once. So that becomes 3.9. That's my answer right there. Okay, pretty easy, isn't it? All right, let's look at B. The B, you're given 17.02 times 1,000. All right, so 1,000 has how many zeros? 3 zeros. That means I'm going to grab the decimal and move it to the right because I'm multiplying. But how many times? 3 times, because 1,000 has 3 zeros. So I'm going to put 17.02 right there, and I'm going to grab the decimal. I'm going to move it 1, 2, 3, and then I'm going to put the decimal right there. The first bubble got 0 in it, second bubble got 2 in it, the third bubble got nothing, you put the 0. So that makes it 17020. So 17,020. That's the final answer. Alright? Okay, good. Now let's look at C. Now C, you're given 248 divided by 100. So 248 divided by 100. So how do we do this? Same principle like the way we're doing for the multiplication. Locate the decimal first. Okay, where's the decimal? I don't see any decimal, but we put it on because this is a round number, a whole number. The decimal is right there. See that? Okay, now you're dividing it by 100. So 100, how many zeros? 2 zeros. When you divide, you grab the decimal, you move it to which direction? To your left, because when you divide, the number gets smaller. So when I move it to the left, it gets smaller. See that? 1, 2. I only move it twice. Why? Because 100 only got 2 zeros. So that makes it 2.48 right there. That's the answer. 2.48. Okay. All right, let's look problem number D. Now D, you got 38.2, and you're dividing it by 1,000. So 38.2, dividing it by 1,000. So what do? Again, grab the decimal, because remember we are dealing with 1,000, 100, 110 with a 1 1. All right, so you can grab the decimal and you can move it to the right or left based on multiplication or division. If you multiply, to the right. When you divide, to the left. Okay, all right, so that means we're going to do what? To the left. Okay, how many times? 3 times, because 1,000 got 3 zeros. That means I'm going to grab the decimal, move it 3 times. 1, 2, 3, and then I'm going to put the decimal right there. First bubble got 8 in it, second bubble got 3 in it, third bubble got nothing, you put the 0. So the decimal's right there, that means you put a 0 right there too. So it becomes 0.0382. That's the answer. Alright, pretty easy, isn't it? Now remember, when you put a decimal right there, when there's a nothing there, put a 0, okay? So don't leave it empty, always put 0.0382. That's the right way of doing it. Okay, good. Now let's look at problem number 4. It's a word problem. Alright, okay. How about Mr. Mac erase the board so we got some room to work on, and I'll be back. Alright, you ready for a word problem? Okay, good. Now, how do we solve a word problem? From a previous sub-lesson, we kind of talked about what do we do? Read the question, understand what's been given and what they're looking for. Okay, so let's do that. Let's extract all the information that's given as we're reading it. Okay, a meter of fabric costs 2 ringgits and 45 cents. All right, Julie buys 7.2 meters. What is the amount she has to pay? See that? So they told us 1 meter costs 2 ringgits and 45 cents. And Julie bought how many meters? 7.2 meters she bought. Okay, that means how much does she has to pay? You multiply. See that? That's the key thing. Okay, so let's problem number 4. Okay, problem 4. So you were told, all right, 1 meter, how much? 2 ringgits and 45 cents. All right, and she bought how many meters? 7.2 meters. That means 2.45 ringgits times 7.2 right there. Okay, so what do we do now? Forget now, remember later. So we're going to forget now, okay? We're going to forget all the decimals, and it's going to be 245. We're going to multiply that by 72. We line it up. So 245 times 72, okay? So once we line it up, now we multiply. 2 times 5 is 10. 2 times 4 is 8, plus 1 is 9. 2 times 2 is 4. Now we're going to times 7. Always lines straight down here. 7 times 5 is 35. 5, 3. 7 times 4 is 28, plus 3 is 31. So 1, 3. 7 times 2 is 14, plus 3 is 17. See that? So now I'm going to add it. 0, 9 plus 5 is 14. 4 carry 1. 1 plus 4 is 5. 5 plus 1 is 6. And then bring the 7 down, 1 down. Alright? Now we forget now, remember later. Alright? That means we're going to remember back the decimal. 1, 2, 3. So we're going to find how many digits behind the decimal. Okay? How many digits? 1, 2, 3 digits. 1, 2, 3. Right there. Okay? Very important. You count it from the back. Okay? 1, 2, 3, and then put that. So that means it's equals to. Oh. Okay? So. Alright, so count it from the back. So 1, 2, 3, 1, 2, 3. So it equals to 17.64. That means it cost Julie 17 ringgit and 64 cents. Alright, because we were told 1 meter is 2 ringgits and 45 cents. If she bought 7.2 meters, how much would that be? Which is right there, 17 ringgits and 64 cents if she buys 7.2 meters. Okay, good. Now let's look problem number 5. Problem number 5, it says a box of candy costs a ringgit and a 20 cents. Okay, a ringgit and a 20 cent. Ali has 10 ringgits and 80 cents. How many boxes of candy can he buy? See that? Do you understand that question? So in other words, okay, we told that one candy box, okay, one box, I'm just going to put one box, is what? A ringgit and 20 cents, alright? We want to find out how many boxes Ali can buy with 10 ringgits and 80 cents. See that? So that means we take 10 ringgits 80 cents divided by 1 ringgit 20 cents will tell us how many boxes we can buy. Alright, so that means I'm going to take 10.8, divide that by 1.2, because we're just going to drop the zeros behind it. Alright, so what approach we're going to do? Forget it. Okay, forget it on this one. So that means I'm going to move this decimal only once. That means when I move that once, this one also move once. Okay, so that means 108 divided by 12. From our timetable, we know 108 divided by 12 is what? 9, because 9 times 12 is 108. Okay? Okay, 9 times 12 is 108. So that means he can buy 9 boxes. So he can buy 9 boxes of candies. 9 boxes of candy for the money that he has of $10.80. See that? So very important to understand how to interpret whether this is a multiplication problem or division problem. See that? Because look at that. A meter of fabric costs 2 ringgits and 45 cents. If Julie wants to buy 7.2 meters, that means 2 ringgits 45 cents, 245 cents, 2 ringgit 45 cents. See that? That means 7 times. 7.2 meters, okay, times, okay, should be 7.2 times, alright, okay, so that's what it is. So we did, so 2 ringgits and 45 cents times 7.2, okay, and then the fifth problem, a box of candy costs a ringgit and 20 cents. If Ali has 10 ringgits and 80 cents, how many boxes can he buy? That means I take that 10 ringgits and 20 cents, 10 ringgits and 80 cents, I divide that by 1 ringgit and 20 cents. And that came out to be 9 boxes. Okay, 9 boxes. Because now see, 9 times a ringgit and 20, 1 ringgit and 20 will give me 10 ringgits and 80 cents to reverse it. Alright, okay, good. The moment I say good, look at Pablo. He's already ahead of. He's been waiting in the corner. He's just like waiting for Mr. Mac to say, time for quiz. And here he is. All right, my dear students. Good. That's a lot of questions, a lot of problems that you solved it, which is good. I'm very proud of you. You did a good job, and go and have fun. Take a break first before you take your quiz, okay? Take a break because that's a long questions, long problems we solved together as well. All right? So take a break and then go and do your quiz. Don't put too big of a gap because everything is fresh in your mind. So when you look at the question, you're going to do well. All right? Okay, go have fun. Have fun with the quiz. And I'll see you the next up lesson. Alright? I'll be here waiting for you because you're the best. Mr. Mac wants to bring only the best because you deserve the best. And it is coming from the best. Alright?